The successful acquisition and implementation of information systems depend upon structured development methodologies and the integration of effective controls throughout the system lifecycle. Modern organizations must develop systems that satisfy business requirements, security expectations, regulatory obligations, and operational resilience objectives while adapting to rapidly changing technologies and business environments. Within the CISA framework, IS auditors evaluate whether development methodologies incorporate appropriate governance and whether controls are identified and designed early enough to mitigate risk before systems enter production. System Development Methodologies. A system development methodology, SDM, is a structured framework that governs the planning, design, development, testing, implementation, and maintenance of information systems. Its primary objective is to ensure that applications satisfy business requirements while minimizing project risk, controlling costs, maintaining quality, and ensuring regulatory compliance. The most widely recognized methodology is the System Development Lifecycle, SDLC, which provides a sequential process for software acquisition and development. The SDLC consists of the following major phases: feasibility study requirements, definition system, design development testing implementation post-implementation review. Each phase should be formally documented, reviewed, approved, and measured to ensure traceability and governance throughout the project lifecycle. Requirements developed during the early phases become the basis for design, development, testing, and acceptance activities, ensuring that delivered functionality aligns with business expectations. The testing phase is particularly important because every business requirement should be measurable and validated through formal test plans derived directly from documented requirements. Additional implementation activities include data migration, user training, operational readiness, and production deployment, all of which should be governed by formal change and configuration management processes. While the traditional waterfall model remains appropriate for stable and highly regulated environments, many organizations have adopted alternative methodologies that provide greater flexibility and faster delivery cycles. These include Agile development, emphasizing iterative development and continuous customer feedback; Rapid application development, RAD, accelerating delivery through prototyping and reusable components; Prototyping, allowing early validation of user requirements before full-scale development, object-oriented, O development; organizing systems around reusable objects and classes. Data-oriented system development, DOSD, beginning with database and data structure designed component-based development, integrating reusable software modules. Web-based development, focusing on browser-based enterprise applications; reverse engineering, analyzing existing applications to support modernization or migration initiatives. Modern software engineering increasingly incorporates DevOps and DevSecOps, integrating development, quality assurance, security, and operations into automated continuous integration and continuous deployment, CI/CD pipelines. DevSecOps embeds security testing such as static application security testing, SAST, and dynamic application security testing, DSD, into the development lifecycle, enabling vulnerabilities to be identified and remediated earlier at lower cost. Development tools such as integrated development environments, IDEs, and computer-aided software engineering, CASE, platforms further improve development productivity and consistency. For IS auditors, evaluating development methodologies includes verifying governance controls, documentation quality, segregation of duties, testing completeness, change management, and alignment with business and regulatory requirements. Control identification and design. Control identification and design constitute a critical component of secure system development. Rather than adding controls after implementation, organizations should identify and integrate controls during requirements analysis and system design so that security, privacy, compliance, and operational objectives become inherent system characteristics. A control objective represents a desired organizational outcome, while controls are the mechanisms implemented to achieve that objective. Control objectives should be established before controls are designed, ensuring that individual control activities collectively support broader business goals such as confidentiality, integrity, availability, regulatory compliance, and operational reliability. Examples of common IS control objectives include protection of information from unauthorized access, prevention of unauthorized modification, integrity of operating systems, controlled system changes, secure software development, availability of critical systems, effective resource management. Each objective is typically supported by multiple complementary controls operating together to reduce risk. Controls may be classified as physical controls such as surveillance systems and facility access restrictions, technical, logical controls, including authentication mechanisms, encryption, audit logs, and automated validation rules, Administrative controls, including policies, procedures, segregation of duties, and security awareness programs. Effective control design follows a defense-in-depth approach, combining preventive, detective, corrective, deterrent, compensating, and recovery controls to address multiple risk scenarios throughout the application lifecycle. Control identification begins during requirements definition by incorporating business functional requirements, security requirements, privacy requirements, regulatory compliance requirements, disaster recovery requirements, technical architecture standards. Embedding these requirements early reduces costly redesign while ensuring compliance and operational resilience throughout production operations. Post-implementation reviews should subsequently evaluate system adequacy, security controls, privacy protections, audit capabilities, and return on investment to confirm that implemented controls continue to support organizational objectives. In conclusion, mastery of system development methodologies and control identification and design enables auditors to evaluate whether organizations build secure, compliant,